Hello, welcome to Old School Chemistry. Today we are going to do the counting significant digits with measurements when measurements are multiplied or divided. If you haven't already, please like and subscribe. Okay, we have one big rule for you. Here it is. I broke it down into two parts. First step that you do is you count the number of sig figs in each number in the problem. And then here's your rule. The answer has the same number of sig figs as the number with the fewest sig figs. Let me do this with you. So we're going to look right here. We have 162.6 times 39.917. Okay, our rules with sig figs. Remember, we never count zero at the beginning. We always count zero in between non-zero numbers. And you only count zero at the end if there's a decimal. So here, counting my sig figs, I've got 1, 2, 3, 4. And here I've got 1, 2, 3, 4, 5. I'm going to write that down as a note so that we can remember it. 4 sig figs and 5 sig figs. I preloaded this into my calculator, and the answer is, let's write this down, 4.07345. Okay, the answer you report to the fewest sig figs from the problem. Remember, we can't be any more significant than the least significant number. So our smallest number of sig figs was 4. Here we go. 1, 2, 3, 4. And I have my students do that. Touch above and count. There's my 4. Draw the line to truncate, and then you always take a moment and look. I call it the bossy number. You look at the bossy number. Does it say round or stay the same? Remember, we round up if it's between 5 and 9. This is a 4. I stay the same. So my final answer is 4.073. There you go, 4 sig figs. Very good. Let's do the next one. We've got 2.0947 times 0.5 equals, okay, let's count our sig figs. There's a 0 flanked by non-zero numbers, so I can count that. 1, 2, 3, 4, 5. Ooh, we never count 0 at the beginning. You have to begin counting with the first non-zero number. These are just placeholders when you have zeros at the beginning. Even if it was like 0.005, you cannot count those zeros at the beginning. So this has 1. Oh, wow, we only have 1. Is that right? Yeah, we've only got 1 sig fig on that. So let's go ahead and multiply. Our answer on this one is 1.04735. Well, my smallest sig fig is 1. So I have to report this to 1 sig fig. Again, we can't be any more significant than the least significant value. So I draw my line. The 0 tells it to stay the same. My answer is a 1. And then for convention, we put a decimal at the end of that. 1 sig fig. Wow. Okay, let's do another one. We have 672.6 divided by 0.70. Oh, I like this number. This is a good teaching number. Let's count our sig figs. 1, 2, 3, 4. And then look at this. We can't count 0 at the end. We can only count 0, can't count 0 at the beginning. We can only count 0 at the end if there is a decimal. And look what we have. A decimal. So this has 1, 2 sig figs. Let's go ahead and get the answer. Our answer on this is 960.857. Well, here I have 4 sig figs. Here I've got 2 sig figs. I'm going to report the answer to the fewest number of sig figs from the problem. 1, 2. Let's do our bossy number. It says stay the same. So my answer is 960. Oh, tricky, tricky, tricky. 960, but I don't want to put a number in without a decimal. And I need to show that this has 2 significant figures. How do I do that? Scientific notation. 2 sig figs. We're going to have 9.6. There are my 2 sig figs. But I have to show it's actually 960. Let's move that understood decimal 2 places. So 9.6 times 10 to the 2. And that's our answer, 2 sig figs, 960. Very good. Little note on this with ALEKS, if you have a number that is larger than the 10, so 100s or bigger, 100 or bigger, or something smaller than the tenths place, so the hundredths or smaller, put it in scientific notation. It's good practice in science convention, and maybe even more important for you right now, that's what I found for ALEKS. You want to put it in scientific notation if it's outside of that range. You're doing so great. Learning sig figs? Super proud of you. Good work. Thanks.